Okay, recorded. Okay, present. Bismillah. Okay, ada lagi yang masuk ni. Okay, so okay, you can see the slide, okay? Okay, so our class today is propulsion. Okay, mengganggu sikit yang masuk lambat ni. Okay, so propulsion class, yes, 3513. So this the prerequisite is aerothermodynamics. So you have taken you have took aerodynamic with Dr. Izani last semester, right? Okay, so today we will do revision, just like the numerical. We do some revision of the past course, past related course. Okay, so but first about the learning outcomes, the objective for this propulsion course. So analyze the operating principle and application of aerospace propulsion engines. Okay, so basically we're going to, you guys are going to I will introduce to you the main aircraft engines, okay, especially turbofan and turbojet that we are going to learn and to apply, okay. And then analyze propulsion problems for aircraft and spacecraft applications. Okay, so there will be also some parts of spacecraft or rocket engine, okay, but the majority of this course will contain the aircraft engine part, okay. The third one is evaluate the design and construction of aerospace propulsion engines and justify propulsion problem in aerospace application. Okay, basically the number 3 and number 4, the outcomes number 3 and number 4, you guys will learn it through assignment, okay. Okay, so the evaluations that I have planned. So as usual, we have tests. One test week 7. I put here week 7 because for numerical we will have test week 6. So try to not have to do the same the test in the same week. Okay, so that is accounted for 20%, and then we have assignment. Only one assignment actually. Just that maybe I'll give you week 12, week 13, or the last week. I'm not sure yet. Okay, so between that week, okay, towards the end. Okay, so that will account for 30%, and I will add just one homework, inshallah, individual 10%, and final exam 40%. Okay. Okay, so this is my schedule teaching plan. So it's a bit different from numerical class because I think since propulsions, we can separate the theory part and the tutorials part, exercise part. So what I have planned is that the theory part I will record a video lecture. Okay, hope that you will watch it individually by yourself, and then after weeks of recorded lecture online, and then we will do tutorial. Okay, we will see each other online like this for tutorial. Okay, because otherwise if I just give lectures like this, just one way communication. Okay, so that's why I prefer recorded the lecture online, and then another weeks we will do tutorial. Okay, so that we have some the online live communication. Okay, so so for this propulsion, this is week 1. Okay, for introduction online like this, and next week and next 2 weeks we will not have the class live. Online live this Thursday morning, but I will record video and upload in Putra Blast, inshallah. So just watch the video. I will introduce the chapter 1, chapter 2, etc. I will explain the theory part, and then week 4 we will see each other. I'm not sure for example, what is the date? 12th April, just one day before Ramadan. 12th April. We will see each other online Thursday morning like this. we'll do tutorial so that we can you can ask me question and we can discuss lah. Okay, and you come prepared lah. Okay, so and then we continue like that. Okay, week 5 I will record again lecture online video and upload in Putra Blast, and then week 6 we will see we will meet for tutorial etc. Okay, and test okay until week 13 assignment. Okay, so actually we for this proportion class we will have less online live class than numerical, because numerical is like mathematic based, so I have to do more online so that I can communicate more to communication with you, right? But this for propulsion we can separate the theory part and the tutorial part, so we will see each other only for theory part, tutorial. Okay, so we only have the purple one, 1, 2, 3, 4, 5, okay, plus the test. Okay, that we will see each other live like this. Okay, because I will see you guys also in for aero lab. Yes, aerospace lab 2 thermofluid, but according to each group. Okay, so I will see group first, second, third, fourth. Okay, so we will see each other a lot actually during each week. Okay, if not for numerical, for propulsion, or for thermofluid lab, aerospace lab 2. Okay, sekejap ni ada je nak masuk ni. Okay. Okay, so introduction. Okay, for introduction of the planning and the class, okay ya. Apa sangat pun, lebih kurang je. It's more or less the same as numerical. Okay, so okay, I'll start. Okay, the introduction of this course, aircraft propulsion. Okay, so basically it's the continuation from aerothermodynamics. It relate a lot with aerothermodynamics or thermodynamics in general. Okay, so because we will learn about the engine, okay, how the engine operates and until we get the power, okay, thrust, okay, etc. Okay, and then also the first part, introduction with the overview of the aircraft propulsion. And then we will see turbojet, turboprop, turbofan, prop fan engines. More precisely, turbojet and turbofan. Okay, because turboprop and prop fan engine, the application is more towards helicopter. Okay, but us, okay, we will learn more about aircraft engine, turbojet and turbofan. Okay, and then engine theory, typical. Okay, the theory part. I mean the theory part of the mechanism of the operation of the engine. So we have to learn from the basic. I mean, understand the theory behind that, which is the main theory, the main physics concept that we are going to apply for the movement or propulsion of an engine is Newton's law of motion. Okay, the basic physics theory for a propulsion engine is Newton's law. Okay, Newton okay, hukum Newton. Okay, so basically today I'm just going to ask you some questions. This is not there are no marks for this, just to do some revisions. So I will ask I think about 10 questions for us to revise back what you guys have learned in aerothermodynamics. And what else? A bit of fluid mechanics, maybe fluid mechanics. Fluid mechanics, I think that's all. Okay, static, I'm not sure. Okay, so the first questions, okay, about aerothermo and thermodynamics, kan? Because normally we heard about thermodynamics, the subject thermodynamics during your foundation, maybe matrix, etc. But when we enter the aerospace engineering program, suddenly we have the subject aerothermodynamics. So what's the difference between thermodynamics and aerothermodynamics, and why the aerothermodynamics part is more important for the aerospace students, civil engineering students? Actually, for the new curriculum, like I have mentioned in numerical class, right now we are preparing for new curriculum. Mengganggu lah yang masuk lambat. Okay. We are preparing for new curriculum, and for the new curriculum, we have taken out this aerothermodynamic subject. I mean, we choose to use the faculty or the mechanical course, common course, thermodynamics. Okay, this is more or less the same, aerothermodynamics and thermodynamics, the content of the course, just that there's one part in thermodynamics, mechanical thermodynamics, we focus more on cycles. There's a lot of mechanical cycles, gas vapor cycles, the thermodynamic cycles, right? But for aerospace engineering and specifically aerothermodynamics, we only focus on the Brighton cycles, right? Because we only use that Brighton cycles for aircraft engine. But for mechanical in general, there's a lot of other cycles that we can learn and we have to learn. Okay, that's why in the basic thermodynamics they have other cycles also. Okay, other thermodynamic cycles. Okay, so what is thermodynamics? That you understand, the thermodynamics deals with what? Which physical value or what? Okay, so I will ask someone. Okay. Oh, okay. Oh, sorry, I didn't see this question. What does it mean assignment offline on week 13? I will give you assignment. So you, you do it online. We will not have on live online session like this. Okay, I just give you assignment and brief a bit, and then you guys do the assignment by yourself. Okay. Okay, first question, what is thermodynamics? I think this is a simple one, just a definition. I think I will call out Nur Syahirah Atifah. Sorry kalau saya panggil orang yang sama dengan numerical. Waktu numerical tak ingat dah. Okay, Nur Syahirah nama. Okay, Nur Syahirah. Are you there, Nur Syahirah Atifah?
Yes, I'm here, doctor.
Can you open your video? Is it okay? You are at the campus or at your house?
At house.
Your own house. Kat mana? Kat negeri mana ni?
KL je.
Okay, KL je. Okay, bolehlah datang bila-bila kan. Okay, boleh buka Syairah. Syairah ke Atifah panggil? Okay. Okay, so what is thermodynamics?
Thermodynamics is like the, how to say?
The main keyword, just give me the keyword. What do you understand about thermodynamics?
Thermal energy convert into another form.
Okay, thermal energy, conversion of thermal energy into another form of energy. Okay, that is your answer, right? Okay. So the keyword there is thermal, I think. Okay, because we can see here thermodynamics kan. So the root word comes from thermo. Okay. Okay. So thank you, Syairah. Okay. So close to correct, okay, but it's also correct. Okay, the Syairah's response. So basically, thermodynamics deals with relationships equation. Okay, the principles of between heat and other forms of energy. Okay, so conversion of energy. But there must be the keyword here is heat, thermal. Okay, thermodynamic. Okay, that's why thermodynamic. So thermo and dynamic, the dynamic of the fluid. Okay. So relationship between heat and other forms of energy. Heat, energy. Okay. So what is aerothermodynamics? Apa lagi? Okay, Farhan Abrar Khan. Are you there? You are from overseas, right? Or you are already? Yes. You're from Bangladesh. You are in Malaysia or outside? Left meeting pula. Jatuh pula. Aduh. Okey lah orang lain. Siapa? Ini. Syed Hafiz? Syed Hafiz, you there? Are you there?
Yes, doctor.
Okay, you are in Malaysia right now or you are outside
Yes, I'm in Malaysia.
Malaysia? Okay, at the campus.
Yes, at the campus.
Okay, can you open your video?
Yes, doctor.
Okay, good morning. Okay, can you answer the questions? The second question, thermodynamics that you understand?
Sorry, doctor, I disconnected.
Yes.
I got disconnected, sorry.
Disconnected? Sorry. Siapa tadi tu? Disconnected. Farhan. Okay. It's
Yes.
okay, Farhan. I ask Syed, okay?
Alright.
I ask. Yes, so Syed, what is the that you understand aerothermodynamics? Just give me some hints, okay?
It's the same as thermodynamics, but it deals with gases at high velocity.
Okay, thank you. Okay, so the keywords here for aerothermodynamics, the extra, the specific, okay, for aerothermodynamics is it deals with high speed velocity fluid, gas, fluid. Okay, high speed velocity. Okay, okay, thank you, Syed. Okay. So next, what is the three principles law of conservation? The three principles, just name the law, okay? Not write the equation, just name the law. Okay, so Farhan, you are here, you are there now, okay? Okay, so Farhan, can you open your video and answer, give me the three example of law of conservation?
Yes, doctor.
Yes. Number one?
Energy is conserved, momentum is conserved, and force is conserved.
Sorry, I hear energy, momentum, and the other one?
Force.
Force. Okay. Energy and momentum is correct, but the force, actually the force is included in the momentum. Conservation of momentum is actually the force. F equal the second Newton law. There's another one.
Work.
Work. No.
I forgot.
It's actually the first one. There's three law of conservation. The first one that you missed. The second one is momentum. The third one is energy. The first one. So the more basic.
I forgot.
Okay. It's okay. Thank you, Farhan. So you have answered two. Okay, Farhan, I have answered two. So there's another one. The first one actually more basic than the other two. So we need the first one in order to get the other two, momentum and energy. So what is this? The first. Nur Natasha Fitri. Betul ke nama dia? Nur Natasha Fitri.
Yes, doctor.
Okay, Natasha boleh buka kamera? Okay, Natasha. Kat kampus Okay, Natasha, senang je. Okay. Satu ni, permis tak jawab lagi. The first one. What is
Conservation of energy.
Energy dah jawab tadi yang nombor 3. Momentum, energy. Yang nombor 1. The first one.
Temperature.
Temperature? Awak sebut temperature ke? Awak sebut apa? Tak dengar. Temperature ke awak sebut? Apa dia? Bukan.
Entropy. Process entropy.
Entropy, no. Entropy is the second law of thermodynamics. Tak ingat Tak apa. Okay. Tak apa. Okay. Thank you, Natasha. Anyone want to answer?
Maths, doctor. Maths.
Maths. Okay. Aizudin, Nakib. Okay. Okay, maths. Or sometimes we call it continuity, equation of continuity. because in order for the to prove that the fluid is continuous, okay, the mass must be conserved. Okay, so that's why we said conservation of mass or continuity equation is the same. Okay. So there's three principles: continuity equation or conservation of mass, conservation of momentum, okay, nanti yang ni saya tanya. Okay, the third one, conservation of energy. Okay. Okay, the fourth questions, mass neither can be created nor destroyed. Okay, that is the rules. How to prove it? Okay, saya tak payah prove kot. No need to prove, just okay, write the equation of conservation of mass. Okay, you have to write it first. Later on, I'll give the answer. Try to think about it first. What is actually there's multiple method of writing this conservation of equation. Jawapan kat sini jadi the answer is here actually. Okay. Okay, equation of, so try to write down in your notebook paper the equation of conservation of mass. This what is at least give me the physical values that we have in the equation. For example, temperature ke, mass ke, mass flow rate ke, okay, volume ke, velocity ke. Okay, so try to think about that. What is the law of conservation of mass? I give 1 minute. You can write it in terms of differential equation, or you can also just the simple equation only have four physical value. Okay. Kat sini. Letak kat sini. So what just give me the physical value. What do we have in the conservation of mass equation? Syahrul Azri. Ni makin kurang, tadi dah 30 orang. Okay, Syahrul Azri, Muhammad Syahrul Azri. Are you there? Muhammad Syahrul Azri. Syahrul Azri. Tak ada di situ. Okay, saya tak, okay, Nakib lah. Nakib ada kan?
Yes, doktor.
Boleh buat kamera tak? Okay, kat kampus ke juga?
Yes, doktor.
Okay, so for this conservation of mass, what physical value yang ada? I mean,
Density,
okay, density,
area and velocity.
velocity. Okay, so you write the basic one, mass flow rate equals to rho A.
Yes.
Yeah, okay, that is correct also. The continuity equation we can write. Itulah nak sebenarnya susah. M equals to rho, tak ada rho.
M dot rho AV.
Malas nak cari dekat dalam ni. Okay, tak apa.
Okay.
So mass flow rate lah. Okay, thank you. So the unit is kilogram per second. Or you can also write in terms of differential equation. Okay. Okay, like this. This copy paste now. Okay. So this is the continuity equation or conservation of mass equation in terms of differential. Okay, so we have the derivation in terms of P for density. So if we say that okay, thank you Nakib, boleh mute kalau nak mute. Okay. Okay. If we said that the fluid or the gas or the fluid is in steady flow, okay, the assumption is fluid is in steady fluid flow, so automatically this term will be zero. Okay, we will cut out this term. Okay, when we say that the fluid is in steady flow. Because steady, we assume that there is no variation in terms of time. Okay, if not, we have the basic. Okay, the equation of conservation is derivation of rho density over times. Okay, means that the density varies depends on the time. Okay, the period of time plus. We have the derivation in all direction x, y, z. Okay, rho v. V is the velocity. Okay, rho v. So equals to 0. So this here the unit will be kilogram per meter cube per second. Okay. Okay. So there's multiple method to write the equation. Okay, depends on the problem. Okay. Okay, next. Next. Okay. Which equation is used? So basically, I'm going to ask based on the law of conservation, the 3 law of conservation just now. So which equation is used to prove the law of conservation of momentum? Write the equation of conservation of momentum for at least one of the axes. Okay, tak apa ni. Okay, but first, equation, what equation? Equation apa? The basic lah equation ni. Okay, I think you must know the equation. The equation used to prove the law of conservation of momentum. Equation apa yang kita guna untuk conservation of momentum? I think I've accidentally mentioned just now. Okay, so what is the equation used to prove the law of conservation of momentum? Azril, Arif. Okay, Syarul.
Yes, Doctor.
Yeah, boleh buka kamera. Okay, apa equation? What is the equation that we use to prove the law of conservation of momentum? Actually, daripada sini mungkin boleh figure out sikit daripada gambar ni. Basic, dia tak susah buat, pendek je, kecil tu kan.
P equal to mv.
P equals to mv. Oh tu, okay, the momentum. Tak, yang ni kan, yang ni macam ni kan. P, tak. Bukan. Any idea? No?
No, Doctor.
Okay, tak apa. Anyone? If you see, okay, for example, we have this one dimension steady flow fluid coming into this cubic, okay, solid. So how do we solve this equation? We use the principle, okay, the main equation of conservation of momentum to solve this. Okay, what is the equation? You have learned this from school, high school. Okay, physics.
F equals to ma.
Yes, thank you, Hasha. F equals to ma. The sum to be precise, the sum of F, the sum of force equals to ma. mass times acceleration, or mass flow rate times velocity. Okay. So that is the basic law of conservation of momentum. So here for this example, the force will be the surface force. So P over A. P over A ke P? Okay. P over A pressure over area. Okay, check balik. Okay, so PA. So ini okay. Tunjuk so F equals to yang ni. F, the sum of F actually. Okay, the sum of F, and this one saya copy ni. Okay. Let's try present. Nampak tak? Ini ganggu bawah tu. Cuba tu. Oh, lazy balik. Okay, tak apalah. Okay, je. Okay, okay lah. At least you understand the principle. So for these types of fluid flow, okay, so we have F equals to the general equation, F equals to ma, and m is A is the acceleration, is the derivation of a velocity over time. So the force, the only force that we have here, we consider the only force that we have is the pressure, PA, sorry, P over A, PA, pressure times the area, the surface force, okay. So depends on the direction, negative, positive, and then so we elaborate the PA, okay, plus PA2, PA1, and then we get, okay, this is the continuity or the conservation of mass just now. Okay, so that's why we have actually we have to know, we have to learn the conservation of mass first, and then conservation of momentum, and then conservation of energy, because we have to apply the first law into the second law. So we substitute this conservation or continuity equation, conservation of mass, in this equation, so we get the differential form of conservation of momentum. Okay. So there's another way to write the conservation of momentum. Okay. Okay. Next questions. Okay, Bernoulli's equation. So this is fluid mechanics a bit. Okay, Bernoulli's equation. What is the Bernoulli's equation? Yang kita tahu. Okay. Try to recall back the Bernoulli's equation. Oh, for your thermofluid lab, okay, thermofluid lab, actually we will do 2 fluid labs, so you have to revise back this, we have to use this Bernoulli's equation and some one lab about thermodynamic. Okay, so what is the Bernoulli's equation? What physical values do we have there? Okay, I ask. Saya tak nampak semua rupanya. Saya change layout sekejap. Tak nampak semua nama. Izzati boleh Izzati? Izzati mesej saya ni tapi saya tak kena muka lagi. Okay, Izzati belum kat video.
Saya ke?
Ya, awak lah. Kenapa ada 2 Izzati ke? Okay. Izzati lain ke kat sini? Tak ada kan? Okay, Izzati. Okay, Izzati. Bernoulli's equation, ada terms ada value apa dalam tu?
Pressure.
Okay, pressure.
Energy.
Awak boleh sebut pressure plus kan, sebab dia plus.
Pressure plus half rho v square. plus rho GH.
Okay. So equals kan conservation. Okay. Okay, thank you. Okay, so the basic law, the basic Bernoulli's equation. Okay. So we have pressure. Okay, example we have two inlet outlet. Okay, fluid. So we have P1 plus 1/2 rho V, rho density, V velocity square. So this is the kinetic energy part. Okay. Plus rho GH, the momentum, not momentum, rho GH, the height, okay, part, okay, rho G, acceleration, and H, the height, okay. So that is the Bernoulli's equation. Okay, next questions. Energy neither can be created nor destroyed, the same as mass. That's why we have conservation of energy, conservation of mass. Based on this statement, write the first law of thermodynamics. Okay, so I've mentioned just now, first law of thermodynamics is the energy equation today. A second law of thermodynamics that I've learned in aerothermo is on entropy, use entropy. Okay, irreversibility kan. Okay, so first law of thermodynamics. Okay, try to recall the first law of thermodynamics. Let me see what's here. First law of thermodynamics. I think this one also ada some different multiple types of ways to write the first law equation. Okay. Yang saya ada ni simple. Tak, kita ada yang time bila orang mencuri rumput. Okey je kan? Tak mengganggu ke bunyi? Boleh dengar suara saya. Okay, okay, Aidil Fauzan, you, okay, you tu apa? What is you? Okay, the answer is correct. It's just that you have, it's better you add the change in you, okay, change. Thermal energy, bukan, thermal, ni, another terms. Internal, okay, internal energy, okay, internal energy equals to Q what? Q is what?
Heat.
Q is the heat, okay, that is the formal notation for heat, Q, we use Q, and W work, and so okay, so the equation, okay, the change in internal energy, you have what inside? The main value in internal energy, you have pressure, temperature, okay, so the change in pressure, the change in temperature, that is delta U, volume, okay, equals to Q minus W, okay, so the heat added and the work done by the system. So that is the conservation law, okay, first law of thermodynamics. Okay, so we have applied this a lot in aerothermo kan. Okay, next questions. Okay, yeah, this is more, okay, this is more about high speed gas flow. Okay, if the fluid were brought to a complete stop, the energy balance becomes what? Energy balance, here we assume no heat, no work interaction, and no change in potential energy. Potential energy tadi sebut. Potential energy, the rho GH. Potential energy, no heat added, no heat loss, no work interaction, and no change in potential energy. So what is the energy balance? Okay, actually, the first law of thermodynamics here, we can also write in terms of there's the kinetic energy, potential energy, all the conservation of kinetic potential energy and internal energy. Okay, so if we assume that there's no work, no heat, and no change in potential energy, so what is the energy balance of a fluid flowing and then suddenly were brought to a complete stop? This is high speed gas flow chapter, okay? If you want to recall about this. High speed gas flow, thermodynamics. Thermodynamics. Okay, high speed gas flow chapter. So, what is the energy balance? Another important physical value or term that we use for first law of thermodynamics or energy. For example, second law, you use entropy, right? Okay, S kan, written as S, entropy. But for the first law, we use the main unit or the main physical value that we use for first law apa? Okay. For first law thermodynamics, bukan word dan. First law thermodynamics, first law thermodynamics, the main physical value that we use for first law thermodynamics. Kalau second law entropy kan, S. Kalau first law apa? Actually just now the change in internal energy Q minus W ni ni yang this is the apa tu simplified equation, the more longer or basic equation. We have used this term apa? Hasha tahu? Enthalpy, ideal Fauzan jawab. Enthalpy H. Okay, so actually first law we deals a lot with H. Kan, within H, U kan, U focus more on the internal energy, but the general equation, longer equation is H, enthalpy. So enthalpy, so here actually you have to write enthalpy equation, okay, and but assuming that no heat, no work interaction, right, for fluid, high speed gas fluid flow, high speed velocity, when it is brought to a complete stop, or stagnant, or we brought it to rest adiabatically. Adiabatic because no heat, no work. Okay, so the fluid is brought to rest or brought to a complete stop suddenly. So what is the general equation? It starts with the first law of thermodynamics, and then we simplify, cut out the heat, interaction, potential energy, etc. So we only have the equation lah, energy balance for fluid. Tak? Ini idea. Enthalpy, okay, so enthalpy plus what? So actually the enthalpy, the term enthalpy here is dynamic and kinetic, the kinetic part. Okay, saya tunjuk je lah question. Because I want to explain. Okay, sini kan, ni daripada buku yang your reference, the main thermodynamic kitab pula kan, book. Okay, okay, so here, okay, normally this is the on the left hand side, this is the general energy balance equation. You have enthalpy, you have this is the kinetic energy. So in the high speed gas flow, we cannot negligible, we cannot cut out the kinetic energy part, okay, because the fluid is in high speed volume, so there must be the velocity cannot be cut out, left out, okay, but we can cut the potential energy because because normally we assume the fluid flow in the high speed is in the same altitude, so there's no potential energy, okay. So and if the system is closed system, so there's no heat and no work interactions. This is the assumption usually made for energy balance of a fluid flow in the high speed gas. Okay, high speed velocity. So we have enthalpy plus the kinetic energy. So enthalpy here, inside the enthalpy here that we have pressure, temperature, etc. Okay. And then if the fluid is brought to a complete stop, so from state 1, dia tengah running kan, flowing, state 1, and then the second part 2, it will stop, so we have velocity V2 0. Okay, so the kinetic energy becomes 0, so that's why we only left with enthalpy, only enthalpy, the temperature, the pressure inside the fluid. Okay, so at the end we only have H2 enthalpy. Okay, because the kinetic energy is already the fluid is brought to stop, so stop velocity 0. Okay, so we also call this as the we also note it as H not or 02 like this kan, not 2, kalau panggil macam mana So this is the stagnation enthalpy. Okay, H02, H02 is stagnation enthalpy or total enthalpy. Okay, tahu kan, total enthalpy, total entropy, total volume, total temperature, total pressure kan, stagnation pressure. Okay, so the term that we use stagnation or total. Okay, so here's stagnation enthalpy because we assume the fluid is brought to stop, so stagnant. So the enthalpy of a fluid when it's brought to rest adiabatically is written as this. Okay. Remember, ingat ni belajar, you have learned this in the, I think the few last chapter of aerothermo kan. Even in aerodynamics also. Aerodynamic 1 or the aerodynamic 2? Aerodynamic 1, did you learn about this in aerodynamic 1? If not, it must be in aerodynamic 2 this semester. Okay? This semester aerodynamic, because I've teach aerodynamic 2 also before, years ago. So it is actually the same as a bit the same as aerodynamic 2, except it's more details about the normal shock waves, oblique shock, etc. Okay. When the fluid is approximated as an ideal gas, okay, with constant specific heats, what is the relation between the stagnation and static temperature? Okay. I repeat. When the fluid, okay, high speed gas flow, still in the same chapter, okay, high speed gas flow, when the fluid is approximated as an ideal gas with constant specific heats, means that we use specific heat apa? CP kan? Okay, CP, specific heat. Okay, ideal gas. Okay, we assume ideal gas. What is the relation between the stagnation and static temperature? Or otherwise you may read it as what is the relation between the total and static temperature? So maybe it's easier to refresh if we read it as total static. So static must plus something in order to get total kan? Total temperature tu consists of static and what? Static temperature and what? Faham tak ke saya shock sendiri je saya? Okay. Actually from this, you can derive this equation from this enthalpy. From this above equation. And then derive to get this below. To get the temperature. So H equals to apa? H equals to what in terms of temperature? H equals to what? Syahirul tadi. Internet dah okay? Syahirul ke Syahrul? Syahirul. Syahirul. Internet okay? Can you answer? H equals to what? In terms of temperature. Ada ke Syairul Faiz? Muhammad Syairul. Oh, dah ada dua kat saya tadi. Tadi Muhammad Syahrul Azri dengan Syahirul Faiz. Okey, saya panggil tadi. Satu kan, tak ingat lah. Tak apalah, Syahirul Faiz. Syahirul Faiz. Faiz. Okay. Okay, what is the relation between H equals to what? In terms of temperature. Ada temperature tu. H equals to enthalpy equals to
Temperature.
H enthalpy equals to apa? Ada temperature dalam tu. Ingat tak? Enthalpy. Ingat tak Syairul? Kecil je, situ je question. H equals to? Oh, actually delta H.
Energy.
Apa
Bukan
dia?
energy.
Yes.
Saya tahu energy plus pressure volume.
Pressure, volume. Okay, in terms of temperature, we can write total temperature, total enthalpy equals to, ni ada CP ni, dah bagi hint dah. Tak ingat?
Sekejap.
Awak nak jawab terus yang ni pun boleh, tapi saya tanya yang satu term tu je, tapi nak jawab terus ni pun boleh. Tengok balik nota aero thermodynamics. Ni dia. Delta H or delta or the total H equals to boleh ke Syairul?
H equal to constant temperature times temperature.
Constant temperature times temperature?
Ni CP times T.
Okay, dapat pun. Okay, thank you. Okay, so that is that is the term lah, but not yet the fully equation for this questions. Okay, so but the main answer is that you have to use from this above equation, just substitute H with CPT. CPT total stagnation, CPT static, okay? So you have so you have this term, okay? So H the total stagnation, H stagnation enthalpy, we can write it as CP specific heat times the total temperature or stagnation temperature T naught equals to CPT. Okay, so that's why we sometimes we call it total instead of stagnation, because the total value, temperature, enthalpy, etc., pressure is in terms of this part is the static value. So here static temperature and static CPT is static enthalpy plus V squared over 2 the kinetic energy part so this is the dynamic. Okay, so static dynamic. So as you have learned first year static, subject dynamic. After you have learned static, then you have to learn dynamic. Okay, so this is the total enthalpy equals to static enthalpy plus dynamic enthalpy, or we can also write in terms of temperature, so divide by Cp. We assume here Cp is constant, but sometimes actually the correct way to write the specific is actually the Cp is in terms of temperature. Cp is a function of temperature. So actually it's a bit wrong, not actually wrong, not correct if you assume Cp is constant. But for normal undergraduate course, okay, we assume Cp constant 1.004 kilogram per joule per kilogram per Kelvin, kan 1004, 1500 apa semua kan. Okay, so but in actual situation, if you do research, experiment, etc., we found out that we will find that Cp specific heat is actually will change in terms of temperature of the fluid. Okay, tapi tak apa, I just want to tell you, okay, that okay. So so Cp here is in constant, so total temperature equals to temperature, static temperature, plus this is actually, this term is also called as dynamic temperature. Dynamic temperature. So means that the temperature actually will change dynamically. Means as the fluid flow with velocity. So actually in real situation, the temperature fluid will change also a bit. So we have to follow that. We have to take that into consideration as well, the dynamic temperature. Sometimes we just cut this off and assume it's zero. But actual, there is dynamic temperature exists. Okay, so next questions. Ni the last two questions, baru 1 hour, okay. Variation of fluid velocity with flow area of a nozzle. Okay, so high speed gas flow, you have a nozzle. Okay, ingat yang nozzle, convergent divergent nozzle, kan? Convergent divergent nozzle tu, CD nozzle tu. Okay, so we need to use the CD nozzle in order to get a supersonic speed flow, kan? Okay. Okay, so variation of fluid velocity with flow area. So we have this sounds familiar to you, okay, looks familiar to you. So we have the general, ada lagi nak masuk ke? Not L. Okay, tak apa. So we the variation of fluid velocity with flow area. So we have this the area in terms the change in area in terms of pressure, velocity and density with MA is the Mach number. You know by now what is Mach number, and another equation in terms of V, the velocity, okay, dA of the derivation A, okay, minus dV over V, 1 minus Mach number square. Okay, so okay, so apa tadi soalan dia? The question is for a supersonic flow, how is the relation between the area A, pressure P and velocity of the fluid flow? How is the relation? Maksudnya means that if area is increased, then what happened to pressure? What happened to velocity for supersonic flow? You try to think about that, okay? For supersonic flow, so if we have supersonic flow, means this equation, the important part is, okay, I'll ask simple questions to, these simple questions to Muhammad Faiz Ridwan. Faiz is tu?
Ada, doktor.
Okay, Faiz belum buka kamera. Mana Faiz?
Yes, sir.
Boleh buka kamera? Nampak dah. Okay, apa tadi soalan dia? Okay, so saya just tanya yang sikit dulu, okay. Kalau supersonic flow, okay, because for a supersonic flow, so what the first thing that we have to assume or have to do lah, okay. So supersonic, kalau supersonic flow, value mana yang apa tu?
MA.
Ha? Apa dia?
MA kan?
MA tu apa?
Supersonic.
MA, what is the MA? MA is the Mach number kan? Okay. So what happened to the Mach number if the fluid is in supersonic flow? Mach number is the value, not exactly so Mach number will be supersonic flow.
Betul.
Apa yang betul? Saya tanya. Okay. Mach number supersonic flow tu jadi apa? Apa jadi kat Mach number? I mean, bukanlah value exact, tapi Mach number is value dia macam mana? Kalau supersonic, kalau subsonic macam mana? Supersonic macam mana? Sonic.
More than one.
The larger than one.
Faham tak soalan saya tadi? Saya
Faham. Tapi
okay. So general dia kan. Okay, untuk revise balik. Okay, so if we have supersonic flow, the Mach number is higher than 1. Subsonic below than 1, and sonic is Mach number equals to 1. That is a simple assumption lah. But according to your friend here, Izzati, right? Mach number 1.2, above than 1.2 for supersonic. That is more precise lah. Okay, betul juga, precise, because between 1 and 1.2 sometimes we assume the flow is transonic kan, the transisi kan, the transition. Okay, okay, so that is correct also. Okay, so first, okay, so we know that for a supersonic flow, okay, kita tengok yang ni dulu, the first one, okay, the relation between area and pressure, kan? Okay, thank you Faiz, okay, kalau nak off tak apa. Okay, area dengan pressure, the relation between area and pressure. So if the supersonic flow Mach number higher than 1, so 1 minus 1, okay, 1 minus 2 or 1 minus 1.5, kan? So this term will be negative, kan? So derivation dA, so we know that the relation between area and pressure is opposite, okay? So it's not proportional, okay? So because means that if the area increase, then the pressure decrease, etc. Okay? So for the term area and velocity, since we have this negative here, so the area is proportional for supersonic flow. Supersonic flow, the area is proportional to the velocity, positive value. So if we increase the area, then the velocity will increase also. Okay, supersonic flow. Okay, supersonic. Okay, yeah, supersonic nozzle. So that's why we have the convergent and then divergent nozzle. We have to use CD nozzle to get the supersonic speed. Okay, otherwise the flow will not increase to supersonic speed if you don't have if you don't use the divergent ducts. Okay, nozzle. Okay, last equations. This is a bit about combustion. I feel like combustion, I mean the simple combustion process in aerothermodynamics. Dia kan chapter tu. There's chapter about combustion. In propulsion also we will learn a bit about combustion as well. Actually, we have I mean if you take a master course, then we have just one solid course about combustion saja. Tapi here we insert the combustion chapter, combustion part in aerothermo and propulsion. So what is the balance? The simple also, the basic right balance equation of a complete combustion of octane in oxygen. So octane C8 carbon 8 kan. So remember we have fuel plus oxygen or air, udara, fuel plus oxygen, then we have a combustion process and turn out into some gas kan, nitrogen semua kan, carbon dioxide. Okay, so what is the balance equation of a complete combustion process of octane C8 octane C8 C8H18 C8H18. Okay, C8H18 octane. Okay, we have methane C4 okay. C8H18 octane. Plus with oxygen. Here we consider only oxygen yang basic aja, not the full air molecule. So there's no nitrogen, etc. So just oxygen, O2. So C8H18 plus O2, and then what will you get? Kan dapat apa? Yang the basic complete combustion. There's no nitrogen here, we assume just oxygen. Apa term yang chemical term that we will have as an output for combustion? Just give me the chemical output. Okay, CO2 and H2O. Thank you Faizal. Okay, CO2 and water. Okay, semua betul. Okay, CO2 and H2O. Carbon dioxide and apalah H2O. So kalau kita balance, if we try to balance the equation, we get this. Nanti besar sikit. Okay. Again, this is a simplify. So in reality, we have lots more other chemical product lah. Okay, so C8H18 plus O2 equals to H2O plus CO2. Okay, at least you know the basic combustion process. Okay. Okay, so that's all the some revision on your thermodynamic, fluid mechanics, aerodynamic ke apa kan. Okay, so banyak kena buka balik buku. Okay, okay, we continue. Tak habis lagi ya. Not yet finish. Apa lagi? Okay, so okay, before we finish, we just introduce a bit about the propulsion or aircraft engine, or we also call it as air breathing engine, classify it as air breathing engine and non-air breathing engine. So this propulsion, aircraft propulsion part, we focus on the air breathing engine. Okay, what is air breathing engine, what is non-air breathing engine? Ini saya tak tulis. Ini tulis. Okay, so basically the air breathing engine, okay, for aircraft engine, so we use oxidizer, okay, oxygen oxygen, there must be oxygen, again in the air we have oxygen. So for the fuel, methane, octane, etc., for the fuel, diesel, etc., in the combustion chamber, combustion process too, use the air itself both as an oxidizer for the fuel in the combustion chamber and as a working fluid for generating thrust in order to generate thrust. So air breathing engine is type of aircraft engine that use oxidizer to for the combustion process of the fuel in order to generate thrust. Okay. Second, what is non-air breathing engine? So non-breathing engine basically the rocket engine. Okay. We use like a store method because the fuel is stored inside the device, propulsion device. So we call this solid. Okay, the fuel as propellant, solid propellant, liquid propellant, etc. Okay, that is for rocket engine. So this is classified as non-air breathing engine. Okay, solid propellant, liquid propellant for rocket. And then what is jet propulsion? So basically the propulsion process of a jet. Okay, like I've mentioned earlier in the beginning, we use the main law that we use is the Newton's third law of motion, which said that for every action there is an equal and opposite reaction. Equal FA, force B, equal and opposite direction acting on the solid or the system. Okay, the moving body is propelled in the opposite direction of jet. Okay, so when we have thrust, and then the jet or the aircraft, the engine will move. Okay, so based on that principle, okay, opposite and equal direction, Newton's third law. Okay, apa lagi? Oh, sebelum tu, okay, ini last. Okay, we will watch. Try to boleh tak tengok? This. Iklan pula sekejap skip. This simple video. Saya suka, I like this video because simple as easy to understand the principle work, how the engine works. Okay, just tengok ni. 5 minit je, 5 minutes.
A jet engine keeps an aircraft moving forward using a very simple principle, the same that makes an air-filled balloon move. Yes, Newton's third law of motion. Just like the reaction force produced by the air moves the balloon, the reaction force produced by the high-speed jet at the tail of the jet engine makes it move forward. So the working of jet engine is all about producing a high-speed jet at the exit. The higher the speed of the jet, the greater the thrust force. The thrust force makes an aircraft move forward. Such high speed.
Okay, so we have thrust, okay, the Newton's law, principal law, and direction, opposite direction, thrust, right, okay.
Exhaust is achieved by a combination of techniques. If you can heat the incoming air to a high temperature, it will expand tremendously and will create the high-velocity jet. For this purpose, a combustion chamber is used.
Okay, so we found out in order to, okay, just now for Newton law, and we have to have thrust, okay, that will push, will propel the engine to move forward, and okay, and then, but in order for the engine to propel, move, we need to have the fluid must be in high temperature, and from lower cold air to exit hot air. Bila ada hot air, when we have hot air, then the fluid will start to move. Kan, bila dia temperature dia tinggi, pressure, there's temperature, high heat. So macam mana? How do we work? How do we get a hot air? Kan? Of course, we have to do the combustion process so that we will get the hot air. Kena bakar dia lah kan? Okay.
An atomized form of the fuel is burnt in the combustion chamber. Effective combustion requires air to be at moderately high temperature and pressure. To bring the air to this condition, a set of compressor stages are used.
Okay, pause lagi ya. So, the second step, okay, in order to get high pressure temperature, kan? Okay, high temperature, we get how we get high temperature? We combustion process. But how to get high pressure? Because normally pressure and temperature they relate with each other. If we have high pressure, then high temperature. Okay. So how to get high pressure? So evidently we have to compress. When we compress something, then the pressure will increase. So that's how compressor came into the picture. Okay.
The rotating blades of the compressor add energy to the fluid and its temperature and pressure rise to a level suitable to sustain combustion. The compressor receives the energy for the rotation from a turbine, which is placed right after the combustion chamber. The compressor and turbine are attached to the same shaft.
Okay, and then we already have compressor, so the fluid will compress and we will get high pressure. Okay, the pressure of the fluid will increase because of the compressor compression, and the temperature increase because of the combustion. And then why we need a turbine? Okay, turbine and then nozzle. because we need to reduce back the pressure and increase the velocity. Okay, because high speed and
The high energy fluid that leaves the chamber makes the turbine blades turn. You can see that the turbine blades have a special airfoil shape, which creates lift force and make them turn.
Okay, so energy, from the combustion process, when the temperature of the fluid increase, kan, because of the combustion process tu, temperature the hot air. At the same time, like I said just now, the pressure and temperature to link with each other. So when we have a hot air, the pressure energy or the energy, that's what you said just not energy, but actually the pressure energy increase. So this pressure energy that we'll use to rotate the turbine. Okay. This one you will see clearly in propulsion lab. Propulsion lab next year. Okay.
As the turbine absorbs energy from the fluid, its pressure drops. Through these steps,
pause lagi. Okay. Nampak the relation here, pressure drops. Bila turbine or fluid tu dia absorbs energy. That is the conservation of energy. Kan, asalnya earlier we have a pressure energy outside of the after exiting the combustion chamber, we have the pressure energy, high pressure energy, and this pressure energy is used to rotate the turbine. So the pressure energy is convert into kinetic energy. So it rotates, and then at the end after the turbine, the pressure energy will start to decrease. So that's why expansion. And expansion pressure energy yang tinggi, pressure at the exit of the combustion and inlet of the turbine tu high, and then the pressure energy is used to rotate the turbine, so convert pressure energy to kinetic energy, and then so the pressure energy will drop. So pressure drop, expansion, kan?
we have achieved our objective, a really hot and high-speed air emitted from the exit of the engine. The engine case becomes narrower towards the outlet, which results in even greater jet velocity.
Okay, so pressure energy drop at the end of the turbine, kinetic energy tinggi, okay, when we mention kinetic energy here, not the rotation of the turbine. All the energy that we mentioned here, pressure energy, kinetic energy, temperature, pressure, it links with the fluid, the air in the engine, okay? Bukan, not the rotation of the turbine tu, okay? Not bila kita sebut kinetic energy, bukan kinetic turbine, rotation lain cerita, okay? Kinetic energy is the kinetic energy of the fluid. Okay, sebab itu that's why we learn aerothermal, so aero the fluid. So okay, exiting the turbine, the kinetic energy is high, okay, but in order to achieve a high speed gas flow, we need a narrow outlet.
In short, the synchronized operation of the compressor, combustion chamber, and turbine makes the aircraft move forward. Modern aircraft use a slightly improved compressor-turbine arrangement called a two-spool. Here, two independent turbine compressor stages are used. The shaft of the outer compressor turbine passes concentrically through the inner one. The outer turbine is subjected to a low energy fluid and will run at a lower speed than the inner turbine. Low pressure blades are longer. This low speed helps to reduce centrifugal stress induced at the root, thus improving the blade's life. Some modern aircraft even use a three-spool engine. The engine we have discussed so far is more specifically called as turbojet engine. Turbojet engines tend to produce high levels of noise. A revolutionary improvement was made to this engine by fitting a large fan with a low-pressure spool.
Okay, this one he start to explain extra lah. Two spool means we have two sets of high and low pressure compressor, high and low pressure turbine, two spool lah. And then how do the technology adds the fan, okay, here at the front of the turbojet. So asalnya the basic is turbojet, and then we add the fan. So it becomes turbofan.
Such engines are called turbofan engines, and almost every commercial aircraft run on them. A turbofan engine bypasses a huge amount of air. The ever-narrowing bypass duct provides a good jet velocity to the bypassed air. In a turbofan engine, the majority of the thrust force...
Okay, so the difference between the turbojet and turbofan is that we have the fan and we have the bypass air, extra air, okay? We will see the first chapter introduction next week, inshallah, what is the function of this bypass air, the extra air, okay?
Force comes from the fan's reaction force. Further, the fan greatly improves airflow in the system by sucking in more air. Thus, it helps to improve the thrust. This means high thrust creation with an expense of slightly more fuel. This is the reason why turbofan engines are highly fuel economical. The noise produced by a jet engine is highly dependent on the exit jet velocity. Since in a turbofan, the bypassed cold air gets mixed with the hot air, it is possible to keep the outlet velocity within a limit. Thus, it overcomes the noise problem. With quieter exhaust and better fuel economy, the turbofan engines continue to dominate aircraft propulsion systems. We hope this provided a nice introduction to the working of jet engines. Thank you for watching this video.
Okay. Okay. So you can look back if you want to watch back the video. Okay, because I think there is a simple and clear introduction to propulsion jet propulsion engine. Okay, so we understand the basic, the theory part, the basic how the engine is designed. Why? Because first, why we from the force Newton's law. Okay, the Newton's law from principle. Starting from the Newton's law principle, reaction and action, and then from there, starting from there, we think about combustion chamber, combustion process, and then in order to get high pressure, then we need to compress, so we add compressor, and then we need to convert the pressure energy into kinetic energy, so we add turbine, right, to reduce the pressure and increase the energy. So that is how it begins, starting from Newton's law, combustion, compressor, turbine. That is the basic, and then until we have a turbofan engine with fan at the front. Okay, so I think that's all. 10:30 a.m. Okay, that's all for today. Of first class. Okay, so attendance. Let's stop dulu yang ni. Attendance. Sekejap, stop record juga.